Hello, friends. You're welcome to Acre Science Confab. In today's chemistry class, we are going to talk about the tiny nature of matter. Matter is made up of tiny, tiny particles. By the way, I believe you still remember what we learned last time about matter, that matter is anything that has mass and occupies space. And now we want to talk about the tiny nature of matter. That matter is made up of tiny particles. Now, how do we know that matter is made of tiny particles? I have evidences to back it up. Now, let's look at the evidences. Number one, I have dissolution of KMNO4. That means potassium tetraoxomanganate 7 is a compound dissolution of KMNO4 in water. You can use that to explain your point that matter is made up of tiny particles. Now, how does it work? If you have water in your beaker and then you have your take very little sample of KMNO4 is a chemical compound, is a salt. Drop in that water. Don't stir it. Don't mix it. Keep it at a corner. Allow it to stand for a long time. You now can see that the purple color of the KMNO4 salt will circulate all around every corner of that solution. You now have one color of the solution. How does it work? Now, the KMNO4 is made up of tiny particles. Water is also made up of tiny particles. This, which are always at constant movement, they are moving randomly, mixing up themselves. The KMNO4 mixing with the water molecules and then bringing around the color, the purple color, to everywhere without you staring. That's number one. Number two is the sublimation. Last time we talked about sublimation during separation techniques, and we said that sublimation is the ability of a substance to change from solid to gas without passing through liquid state. Now, if, for example, you have camphor, you bought camphor and put in your box, and then when you bought it, it was big, and after some times you go back and check and it become very small. What do you think has happened to it? It sublimes. Particle of it have continued to change from solid to gas. If it is melting, you would have seen liquid there. But now you have not seen liquid. That means it's changing to gas, escaping into the atmosphere. So that substance is what? Subliming. So that we can use it and explain that matter is made up of tiny particles, because if you can stand there for as long as possible, watching the time the particles of the camphor will cut and disappear, will cut and escape, that you will see it, you will not see. But what you will observe is the reduction in the size. That's what, because the particles that are living are very tiny, you will not see. Okay, now let's talk about diffusion. Diffusion, for example, if I bring perf now and spray perfume, spray it here. That initial time, you who is standing there a little bit far from me, you will not perceive the fragrance of the perf that I spray. But with time, because it is tiny in nature, it will move in the air, fly in the air, from here to where you are. And then that's the only time you will now perceive the fragrance and say, I like the fragrance of your perf. Why? Because at that moment, the particles, the tiny, tiny particles of the perf that I spray have moved down to where you are. That's the reason you are perceiving it without you seeing them flying like birds coming. Okay, now the last one here is Brownian motion. Brown is the name of a person, and he was a great scientist, a botanist. He was working on pollen grain using powerful microscope, and what he saw, pollen grain, very tiny substance, particle. He dropped it in a pool of water, and he expected it to remain in one place. But what he observed was that the pollen grain was being pushed in a zigzag way, and he was shocked. The pool of water is steady, but what is pushing the pollen grain? Pollen grain is not like ants that you see that it has hand, it can swim. It's supposed to remain in one place. And the man now made more research, and he discovered that molecules of water are at constant movement. They are moving randomly, hitting the pollen grain to this side. Another one is hitting it to this side. Another one is hitting it to this side. Another one, just like that. That was what brought about the zigzag movement of the pollen grain when he himself did not see the water molecules moving. So that is to say that even water has tiny molecules that are at constant movement. So with these 4 points, matter can be proved that they are made up of what? Tiny particles. The tiny particles of matter that we are talking about might be in the form of atom, molecules, ions. Now, let's start with atom. What is atom? I mentioned atom here. An atom is a smallest particle of an element which can take part in a chemical reaction. Example of an atom, when I talk about hydrogen as an element, an atom of hydrogen is just H. An atom of oxygen is O. An atom of chlorine is Cl. Atom of sodium is Na. You have known all these. They are atoms of different elements. Now, let's know what atomicity is. Atomicity is the number of atoms in one molecule of an element. Example, helium, neon, argon. They are one atom per molecule. When we say one atom in one molecule, we are referring to monatomic substances. Some substances are monatomic, some are diatomic, some are triatomic, some are polyatomic. Now, the monoatomic, that's one atom to one molecule. They are the ones that I mentioned here: helium, neon, argon, etc. They are all monatomic. Some substances that are diatomic, that's two atoms to one molecule. We have uh, we have hydrogen gas, oxygen gas, chlorine gas, fluorine, iodine, nitrogen, and so on and so forth. They are all what? Diatomic molecules. That's two atoms to one molecule. Now, considering ozone, ozone is triatomic, meaning three atoms to one molecule. Phosphorus and sulfur, they are polyatomic. Phosphorus has four atoms in one molecule, while sulfur has eight atoms in one molecule, and the two of them are called what? Polyatomic. Now let's see molecules. A molecule is a smallest particle of a substance that can normally exist alone and still retain the chemical properties of that substance, be it an element or a compound. Example, very small unit that still possess the chemical property of that substance, like hydrogen molecule. Remember, the difference between hydrogen molecule here in the formula is that from the one we were talking about, a hydrogen atom. Now let's consider molecule. A molecule is it's the smallest particle of a substance that can normally exist alone and still retain the chemical properties of that substance, be it an element or a compound. Molecule can be an element, it can also be compound. Example of molecules: hydrogen, oxygen, neon, argon, ozone, and so on and so forth. Now, if you can recall, I told you that an atom has one hydrogen as an atom, whereas molecule has to do with two atoms of hydrogen. The same with oxygen. But neon, whether an atom of neon is one molecule of neon. The same with argon, the same with ozone. One atom of ozone is just oxygen. Oxygen, one oxygen. But molecule is what? Three. Now we move to ions. Remember, I mentioned atom, molecule, and ion. Ions. What is an ion? An ion is any atom or group of atoms which possesses an electric charge. When one atom or two or three, as the case may be, share the same charge, whether positive charge, plus or minus, that's an ion. Now, we have two types of ions. One is cation, and the cation is what? Positively charged. Those ions that possess plus, that carries plus, they are cation. Those ones that carries minus, they are negatively charged. They are what? Anion. So the example of cation include Na plus, Ca2 plus, that's sodium ion, calcium ion, aluminum ion, ammonium ion, and so on and so forth. We also have anions, those ones that are carrying negatively charged. Example include chloride ion, nitrate 5 ion, OH, hydroxide ion, tetroxosulfate 6 ion, triazocarbonate 4 ion, oxygen ion, sulfide ion, and so on and so forth. Now let's consider Dalton's atomic theory and the modification. What this unit is talking about is the theory that was propounded by Dalton and what it is today. Now, Dalton said this side is Dalton atomic theory. These are the atomic theory that Dalton proposed, and these are the modifications. Let's see whether the body of the scientists agreed with all what Dalton said here. Number one, Dalton said that all elements are made up of small indivisible particles called atoms. All elements are made up of small indivisible particles called atoms. When you say indivisible, you cannot break it any further. But the modification says this statement has been proven wrong by Rutherford, the discovery of subparticles of atoms. Rutherford discovered that atoms has particles that are proton, electron, and neutron. So because of that, the theory was not acceptable. Let's go to number two. Dalton again said that atoms can neither be created nor destroyed. You cannot create atom. You cannot also destroy destroy atom completely. This was what Dalton said. But let's see the modification. The modification said this statement still stands only in ordinary chemical reaction, but not in nuclear reaction. That means that in normal chemical reactions, it still stands, but not in nuclear reaction. Nuclear reaction, you can destroy an element to produce another element. Like in the case of this, uranium was destroyed to produce thorium and helium. Thorium and helium are not exactly alike with uranium. You destroyed it to produce these two. Now, let's see the element itself. They are different. This and this are different from this. The atomic number of uranium is 92. Atomic number of thorium is 90. Are they the same? No. The atomic number of helium, 2. Now, the mass number of uranium is 238. The mass number of thorium is 234. The mass number of helium is 4. Are these exactly the same with this? The answer is no. So, because of that, the second Dalton's atomic theory is not accepted completely. Now let's go to the third one. Atoms of the same element are exactly alike in every aspect but differ from atoms of all other elements. Is it true? Atoms of the same elements are exactly alike but different from other atoms of other elements. It is not true, because the discovery of isotopes of elements made it unacceptable, because atoms of the same element are not exactly alike. Now, what is isotopy? A situation whereby you have the same element, atoms of the same element having the same mass number but different mass number. Like in the case of chlorine, you have chlorine is an element, you have chlorine, the same element, the elements are the same. Now, mass number 17, they are the same. But, atomic number, not mass. Atomic number, 17 and 17. But considering mass, 35 and 37, are they the same? No. So, atoms of the same element are not exactly alike. Now, let's consider number 4. During a chemical reaction, there is a combination of atoms in small whole numbers. Dalton said that during chemical reactions, the substance that goes into the reaction must always be of small whole number. But the modification says this statement is true only for inorganic compounds, which usually contain a few atoms per molecule, but not true in organic compounds. Example, protein is an organic compound. It contains thousands of atoms present. The same with fat, the same with starch. They contain thousands of atoms. So the statement is not true. I believe you enjoyed the lesson. Like the page, share and comment. Till we meet again some other time. Enjoy yourself.